Thank you very much. Hello, everyone, and welcome to the first EIP-7928 breakout call. I thought it makes sense to have a breakout call around the EIP now on a more regular basis, just to keep track of progress happening. On today's agenda, there's not that many topics, but we still have some open points to discuss. And I would propose that we start today's first breakout with Jared talking a bit about the implementation progress he made in GEF. Then there is Rahul, who will talk a little bit about testing progress and everything that is happening on the testing front. And then we have Chen from the ETH storage team for Quark Chain, who will present some results on their performance analysis of block level access lists in GEF. And before we start getting into those topics, let me just quickly recap some info around the EIP. First of all, on block access list.xyz, I posted it into the chat. You should find all the important information, especially if you scroll down to the resources headline. There you find all the specs, like the EL specs, the execution API specs, and the CL specs, as well as test cases and everything. So this is kind of the place where we try to bundle all that information. And yeah, everything is summarized there. If you want to submit new test cases, then Rahul will show you how to do so. There's a dedicated testing doc where we collect many test cases. But yeah, without further ado, I would say, Jared, would be pass it to you in order for you to present us some initial results you collected on GEF.
Yeah, cool. Yeah, so I can just to summarize where the Geth implementation is at right now. We fully implemented the EIP except for storage and account reads. Uh, so basically at this point, um, I, we're we're more or less ready to do a DevNet in the sense that the code is written and I'm reasonably sure that the consensus API, the engine API changes and the minor changes should work. But I'm still verifying that on my end. The execution, so block access list execution and building are are implemented, and I've done quite a bit of work to get the performance to a reasonable point. So I guess I'll just share my screen. I have a few slides just kind of summarizing the latest benchmark. Where? I'm used to Google Meet, so okay, so I'm just going to, it's like I have to give it a permission here. I have to rejoin the call.
Karim, I think this is a good point. Regarding the reads, I think this is still up for discussion. So far, my feeling was that the majority of people is still for including the reads, just because parallel I/O might be very valuable, especially with bigger blocks. But yeah, this is still something we have to discuss. Okay, Jared is back. Jared, are you already talking? Is it just
You're muted.
Jared? Can you hear us? You're still muted.
Yeah. Oops. Okay. Yeah, so just to overview of the serial execution that Geth currently performs, we execute transactions one after the other. Simultaneously, for mutated state, we will fetch intermediate trinodes in the background so that when we go to compute the state root, it's fast. Oh, this is the wrong slide. Oops. Yeah, that's the next slide. Okay, so right, in block execution, compute the state root hash. We validate block fields and the state root hash against what's reported in the block, and then we write the mutated state to disk. Block access list execution parallelizes the transaction execution and the state root calculation. So in this model, we don't have the advantage of being able to prefetch trinodes in the background, but when we go to commit, we can do everything and we can commit all of the node, or when we go to compute the tri-root hash and we have to fetch the intermediate trinodes, we can do this all in parallel. So it ends up being not a huge performance hit. So when we execute transactions and simultaneously calculate the state root, we provide an empty pre-state to these like worker threads, and then they will sort of like compute the state they need to execute against by looking at the access list. And then some of that information is also supplemented from disk. Block access construction, yeah, like I mentioned, we haven't implemented reads. I was kind of under the impression we would remove them. It sounds like we'll talk about this today. For writes, it's pretty straightforward. When we go, yeah, it's pretty straightforward. All right, so can you all see my mouse?
Yes.
Okay. So the performance of the master branch is the overhead is dominated by the execution. So these first three columns, these first three rows are, if you sum them together, this is the time it takes to perform the execution. So then when we go to update, the account update here and then the storage update here are fairly quick because we have pre-warmed trinodes while executing transactions. But the actual transaction execution time is large. I should also mention, so these numbers I'm giving are a benchmark of an import of 10,000 blocks. It's not a huge span of time, and I'm running a longer benchmark now, so I will have some updated numbers soon, but right now this is what I have to present. So, right, so with the BAL branch, on this benchmark, so the performance is overall, the block processing speed's about 2.6 times faster. So the state root calculation here is our slowest, but the block execution is very fast. And then so these block pre-processing is we can kind of ignore that because that's just this branch was a work in progress when I performed these benchmarks. But I think that this step and the pre-processing state loading is actually just a component of the pre-processing steps. So it's not like an additive. You don't add all these up to get the total the total time it took to process the block. But I think that this step actually can be optimized away. And I'll be working on that at some point over the next week or two. Um, right. So, I mean, yeah, this is kind of what I have right now. And I think that I've been running a longer benchmark, and there are definitely uh, spikes. So here the execution is like fairly reasonable, but I've definitely seen some spikes where the execution is actually in general on par with the state root calculation so far as what I'm seeing. Um, and yeah, so I will be continuing to benchmark this and try to improve it. Uh, I think right now, though, from what I've seen with the latest results, I think at least 2.2x or slow or 2.2x or so speed up seems to hold. And I mean, I'll have to run more benchmarks to actually see what the master branch performs over this longer period of time that I'm measuring. But yeah. So that's pretty much my update.
Awesome, thanks. Just a quick question. In this, when you say execution and
Oh, okay.
you didn't do any parallel I/O in this model, right? Because you said you were not using the reads yet or the state locations.
Well, so the IO is parallel because they're executing in parallel. So I think like a
True.
good portion of the speed up is actually due to the parallel IO. But yeah, it's not executing with the reads, and also, um, I mean, I can definitely measure reads. It's doable. It kind of involves adding a separate component, but it can be done.
Right. Yeah, this also plays into this what Karina is saying in the chat, that if
My
we have the state locations, then you can do something like batch parallel I/O. But if you don't have the read locations, then you can still do some parallel I/O because you already parallelized the transactions.
Yeah. Just to answer this question, so uh I don't think we need to do batch. I'm not exactly sure what this question is, but I don't think that we need to do batch IO up front. I think we can just start executing. Like we don't need the pre-state completely loaded at the start, if that's what this question is getting at, right? We can just start executing and then load things in as we need them. Um, and I mean, with the reads also, it's like it doesn't really make sense because they're not indexed by where they occur in the block. I think that parallelizing loading them up front would actually be, I think it would be slower personally. Um,
Right. Yeah, this is a good argument. And then the question becomes if we don't put the state locations in there because they give us some certain amount of speed up, are there other reasons why we keep them in? And one of the reasons could be that we just have more information in the block level access list. We don't only have the information that changed, we know what changed and in which way it changed or to what it changed. And then we will also know like what was accessed. Um, yeah,
yeah, definitely. I would say in that case, it would be it. I wonder if there what the usefulness trade-off is. Like if there's information that storage slots were accessed in a block, but we don't know what transaction they were accessed in. Um, I yeah, I guess I'm just wondering how that would be used. But
Okay, and so
but to answer the question, that batch load is Yeah, I mean, I can measure it. We already in the benchmarks I presented, there is actually some batch loading up front of the pre-state that gets modified, and it adds, I mean, maybe like 10% overhead overall. So,
Cool, thank you. Yeah, Jen, did you wanted to say something, or do you wanna just continue with presenting the work you guys did?
Yeah, actually, when we are doing the benchmark, uh, and we use some of the uh, content storage slot to use this information to do with this information we can do some kind of this snapshot and to accelerate the block process the execution time. I don't know if I expressed my opinion correctly. Yeah, because
Okay, so you say the state locations would also be helpful for execution.
yeah, yeah, because there are two options. One is like Jared did. Uh, you fetch the mm, storage and account state during execution. Yeah, the second option is you just prefetch all the pre-block state, then executing. Yeah, the benefits of the prefetching the state is that you can do some snapshot because we know all the pre and post transaction state. This state we can kind of do multi-layer state reading. Yeah, we can snapshot every about, for example, 10 transactions, and then we can make a day snapshot. Uh, then if we want to adjust the state, we could just uh, uh, do a kind of a multi-layer reading. Yeah, and this will accelerate the state rate.
Okay, is that part of the benchmarkers you're going to present?
Yeah, it's part of the results, but I didn't write presented the routine on my presentation. Yeah.
Okay, no worry. Okay, yeah, it would be nice if you could share those results with this group. Would be very interesting to look into this because I think you also did some analysis on um, what happens if we 10x the block size, right? If we have suddenly like 10x the gas limit, how would that impact execution time versus IO time? Ah, perfect. I see you posted it into the chat. Great. Yeah, I agree with Carl. I think we should get some better benchmarks on what do we actually get from batch.io.
hey Poe, I have a quick question about this slide you just posted. So the speed up at the bottom, is that uh versus master, or what is that based on?
Uh, Let me rephrase your question. You mean master is the main branch of gas?
Yeah.
Yeah. The version is uh, yeah, in the second PPT is 1.16. It's close to the latest version. The latest version is 1.1 716.2, and my version is 1.16.1. Yeah.
Gotcha. Okay.
Okay, and if I interpret it correctly, it's like the result is also like a 2x speed up for average cases, right?
Yeah, right.
I mean, I want to just highlight again that we care about worst case, which is a 33x speed up supposedly.
Right, yeah, that's a good point. Because if you use like 32 cores, like as this experiment did, and we would have had like worst case blocks, then we would have gotten a 32x speed up. But even for the average case, like a 2x sounds already like more than I expected. Of course, I expected like big performance improvements for worst cases, but like 2x for average cases is already like very good. But yeah, it would be interesting to find out like if clients actually need the state locations to do something like batch IO up front, or if we remove them. And in the end, it's not only do clients need them, but should the protocol have them? Maybe there are some use cases that we're not aware of yet that might need them.
And we also need to weigh that off against the like cost and time of sending that over the wire. You know, they're not free to add or sorry to have.
Right. Yeah.
It's also possible that if we can batch the storage lookups, so for red storage and red accounts, if we can do that up front, but kick that off after we've started performing the state root calculation, I mean, I could see that being an interesting route to benchmark and explore.
Can you say a little bit more about what you mean by after the state root computation?
So the if we batch load non-mutated storage slots and accounts up front, but we haven't yet started to compute the state root calculation, we're adding overhead up front and delaying work we could already do. Because like the mutated storage slots and accounts aren't needed you don't need to load them to compute the state root.
Okay, I'm not following here. Like, don't we need the post state? Like the root of the post state at the end of the block?
Yeah, sure. I thought we were talking about the like when we say batch IO up front here. Yeah, I'm just saying like if we can of course batch the loading of the mutated accounts up front. That's the only like precursor, the mutated accounts and the mutated storage slots up front, because that's the only precursor for performing the state root update. Um, but we wouldn't also need to warm the uh, any storage slots or accounts that aren't mutated
Mm-hmm.
before we in parallel start the root computation.
Yeah, I see.
I'm kind of just thinking aloud here,
Yeah,
but
yeah. I mean, I think a lot of the thought process comes back to like Dunkrat did some experiments a while ago just on like batch random reads. It was a very contrived example, but he got something stupid like a 50x speed up on loading arbitrary data from an SSD. Just by doing batch reads as opposed to individual reads. So I think that's where like a lot of the intuition of like, oh yeah, it's probably worth just like fetching all the state, whether it gets mutated or not. Like before the execution starts.
yeah, I mean, I definitely agree that I would definitely say that like I haven't benchmarked reads. It appears that the work from eStorage and or Chen, sorry, it appears that they've started
Yeah, you can call
out.
Paul. But is my family name. Yeah, Paul is my English name.
Okay,
Yeah.
okay. Yeah, I mean, it, it's definitely worth exploring, yeah, for sure. I'd like to benchmark it, and I intend to.
Okay, fantastic. Yeah, I think that there's like so much here that's like, oh yeah, there could be one trade-off here or one trade-off in another way, and it's like benchmarks. I think are the only way of answering these questions.
Which exact benchmarks are you thinking of here, Jared? So which benchmarks would you? Because this should be something like very simple to do, right?
Yeah, so I would implement reads, and then I would benchmark them against mainnet as a start. And yeah, I mean, just batch loading the red storage slots up front and see what kind of performance, see what the results are. I mean, yeah, like I said, there's some interplay with like the state root computation. So implementing it is, I mean, it's not very complex, but there's definitely, yeah, I mean, yeah, just benchmarking it against mainnet and seeing if we can fiddle around with the implementation to yield performance gains.
I think it will also depend on how we implement the block processing, because I said if we want also to compute the state root from the beginning, we'll have also to batch or try to read the intermediate node of the tree in order to compute the state root. If we have also to batch the read, so we'll have a lot of things to read at the beginning of the block. I feel that it will be maybe better if we can mix between IO and CPU. So as I said, if we are running all of the transactions at the same time, sometimes we have IO, and during IO we can run something else, an EVM code or something like that. But if we do all of the batch at the beginning, we just wait at the beginning of the block to finish all of the IO. And I don't know if it will be better or not, just asking like that and thinking about that.
Yeah, I think it's a fair comment. I think we only find that out if we do some benchmarks and then we see. In the end, it's like the absolute time it takes to execute the whole block. Doesn't matter if we do it upfront or during execution. So yeah, I think we just need some benchmarks at this point to figure it out. Would be great if we can even get them from multiple client to just have some more certainty on that decision.
Yeah, actually, yeah, all the and as Jared said, the execution time will the try preparation time. So that's why
Yeah, I think we can't really hear you. Oh, I think your mic has a problem.
okay. So is it okay now?
Try it again.
Okay. So I think I will have to change my mic.
No worry. Perfect. Right. Yeah, I think we can end that topic regarding reads. And at this point, we agree we need some more data to figure that out. So I would say let's move on to the next agenda point, which is Rahul telling us something about the testing efforts going on. And also Felipe is on the call. Would be great to hear his perspective on updates from him too.
Hey, so I'm going to quickly go over some updates on the testing front, give you some updates on the progress, give you a brief overview of how the test works under the hood, and then a couple of housekeeping items. So the test mainly depends on two repositories. One is Yeast, which is like a Python testing framework, and we have Eels, which is like a Python implementation of the spec. We have both of those working now. We're currently trying a basic set of tests, about 5 test cases, and reviewing how that is being executed. Once we are confident with that, we'll do a small release where, as clients, you guys can just start integrating these tests as part of your development cycle. And then we'll keep on working on more complex tests later. Yeah, so Felipe is like doing the integration testing now. He's on the call to like give you an overview of how the test works under the hood. Over to you, Felipe.
Yeah, sure. So right now there's, as Rahul mentioned, there's the spec side written in Python and the testing side as well. So what I did was some work trying to bridge Tony's PR on the spec side with Rahul's on the testing side, and we got it working through. There were just some changes to your PR, Tony, to just pass things through the T8N tool, the transition tool that's talking across the testing and the specs. And so basically, I got this working. We do have some of the basic tests Rahul is working on. Right now, I'm figuring out how to make the developer experience a little better for adding some complex test cases and some invalid checks. But as it's working, this is like a general flow of East here. Transactions are sent over to the specs to fill these fixtures. Eels is the specs in this case. They receive the block. They will build the block access list and they pass it back. So what we pass back to the testing right now is the hash and the header and the ROP encoded block access list from the specs. What we do on the testing side is we define some smaller subset of the block access list that we care about for the test. Some of these tests will have the full subset, right? Or it'll be like a full check on the value that's returned. But sometimes we only care about certain things. And so we do perform this check, but we also rehash the full access list and check it against the hash and the header. So we always have this double check on the testing side. And yeah, Rahul, is there one more slide? Yes, perfect. And so here, this is basically like once this fixture is filled with the specs, and this is a common flow for the testing as well. This can be consumed by clients over Consume Engine, and so this just kind of shows the flow there as well. But those are the updates on my side. I do actually have initial implementation of this like more complex model structure to start working on the invalid tests, and I did write a couple invalid tests yesterday, but that's still a work in progress. But it does seem to be working well at the moment.
Thanks, Felipe. Another thing that we noticed was there are some creative tests that come from devs, but they're often lost in Discord messages and GitHub issues. So we're trying to aggregate that as part of the repo itself into a Markdown file. This is like a structured Markdown file which goes over the goal of the test, the setup that is required, and the assertion that we're trying to make. So if you guys have any test cases in mind, I'd suggest making a PR to this Markdown file, and we can probably use that to make discussions, give progress updates, and for other high level activity on and the test cases. We also are using this Markdown file along with the test case to integrate into Hive, which is like an integration framework which talks to all the clients to create like an adoption dashboard. This is what it looks like. So this pulls in the data from the Markdown file in a way that's easier to read for people to understand what's happening under the hood. It also fills in the Python test against each client using Hive, and then shows an update on to a matrix here. This runs on a CI server, and this is how it looks. You can tap on a test to see what exactly it's testing. And yeah, obviously there's a link to the Markdown file for you guys to create a PR. Yeah, that's all from us. Thank you.
Awesome. Thank you very much, both of you. Yeah, I posted your Markdown file, the link to it in the chat. Would be great if client devs, every time they come up with a new edge case, can do a PR against it. We already in the Discord I saw yesterday, I think. Can't find the message right now, but I think we already stumbled across a few edge cases where certain clients would have put that certain address into the block live access lists while others wouldn't have. And in the end, I think we just need a lot of those test cases to, yeah, get to a clean implementation. Perfect, thank you. Right. Finally, I just wanted to ask clients about progress. It would be nice if client teams could just quickly give a little bit of an update where they are, what they think about the EIP, and if there are any blockers or anything where we could help. Maybe we can start with you, Jared.
Yeah, so we actually have our first review call on the PR tomorrow. So yeah, from my side, not much right now, but maybe that will change after tomorrow. So
Cool, thanks. Is there someone from Besu here?
Yes, but maybe you can talk, Mirgi.
Yeah, sure. So, in Besu, we have implemented a degree of protocol support for BLs. But we still need to update the engine API, and it's possible that we haven't incorporated latest spec changes. The PR has been open for about a month with little changes, and it's possible that we are mishandling some of the edge cases. For example, I'm aware that we are omitting the system contracts from BLs completely for the moment. And we've been testing against the ETH analysis repo and getting good results there for what that was. Yeah, but the PR has been blocked on some issues, but otherwise, um, that's I think that's our status. Yeah.
Awesome, thank you. Is there an update from someone at Aragon?
Yeah, hi, it's Mark Colt here. I'm doing the BAL implementation at Aragon. Status is I'm just starting. So I'm probably by the end of this week, I'll have an estimate of how long it'll take to get to something that's working. I think we're just in the middle of merging. We've got a parallel execution engine that we've been working on for some time, which is just going into main. So I think the work to support BAL is going to be just integrating the engine API and making sure that the data structures that we've got essentially are mappable, which, looking at the spec, I think is a relatively straightforward process. So, I mean, if it goes well, probably a couple of weeks will be in dev testing, I would guess. If it goes badly, probably 3 or 4 weeks, I think is where we are.
Thank you. Yeah, just to directly address Karim's comment about that it would be nice to have a configuration ready for the first DevNet, especially decide on things like, do we want to put reads in there or not? I would say right now the EIP is still like with reads, so I would still stick to having the reads included for now. But yeah, we can still, as said, as soon as we have some benchmarks, we can take a final decision. I hope that we get the benchmarks before we get closer to a DevNet, so that we have the benchmarks rather soon, so that we can decide on that earlier. Yeah, thank you, Mark. Is there anyone from Ref here?
Hello, we are currently working on the engine API changes. Just today, we have done the new version 4 payload structure.
Awesome, thank you. Did you start with the engine API, or with which part did you start there?
No, we have implemented the reads and writes storage part already. We are currently recording both the reads and writes.
Thanks. Do we have someone from Nethermind?
Yeah, hello. So I've started prototyping block access lists in Nethermind. So far, I've been focusing on the sort of construction part, which has progressed pretty well. So the sort of construction and serialization. And the way I decided to sort of approach it is to split it into 2 PRs. So there's the one which is like the construction, and then the other part is actually using the block access list, so all of the kind of parallelization aspect. And I haven't really worked on that part of it as much, and it seems like it will be significantly more kind of complex. But the way I kind of understand it from the spec, it does seem quite logical to split it into those parts, because you could almost just do the construction without necessarily leveraging everything. So that does seem to give us a little bit of kind of flexibility there in terms of scheduling. I'm not sure if anyone else has approached it that way. But yeah, that's it for now.
Great, thank you. Yeah, if there's nothing else that we want to discuss today, we can enter call. This was basically everything we had on the agenda. I note that we still need to do the benchmarking to decide upon do we want to include the reads or not, or not the reads, but the state locations. This is kind of the same here. And yeah, and then we can discuss about the first DevNet. I think Gev and Beso might be the first clients that might be ready. But yeah, as the EIP is not that big, it would be cool to get a DevNet, to get to a DevNet as soon as possible.
So, yeah, I guess, yeah, based on Carl's comment earlier, I personally kind of lean towards keeping reads in until we can demonstrate worst case performance, which isn't trivial. So it would be nice to keep those in until we can set up some kind of like attack net where we spin up a bunch of these like worst case blocks without reads. Sorry, that I just realized that didn't make sense. I want to evaluate like what the worst case performance is without having the reads before we decide whether or not to remove them. So yeah, at least yeah.
Yeah, that's fair. Perfect. Yeah, the EIP as it stands today still includes the reads, so I think we just leave it as that, and then we can still decide at some point if we want to remove them or not. But for as a default, I would suggest we keep them for now. Perfect. I see, Mark, you have your hand. Yeah.
Yeah, I just had one quick question. So I saw on the agenda something about RLP versus SSZ. I've gone with implementing RLP, and it seemed like last ACD that was agreed upon, but I just want to check, are we kind of all in agreement that we're going to use that?
Yeah, so just to summarize this was on all Dev's call, I think last week. I think most people didn't have a strong opinion, but it seemed like the less complex way would be to just go with RLP and not use the EIP to introduce a new, SSC. This is kind of also the default that is now in the EIP. I think we have some broad consensus on that, but I'm happy to discuss that if anyone else wants to, defend SSC.
Yeah, I mean, I think RLP makes sense to me.
Yeah, there were some pros and cons for both, like SSC with smaller, more compact proofs might have some advantages there too. But RLP in the end, it's smaller, so we save like 10%, 5 to 10% on the size, which is negligible, but still. And it's just known. So all clients have code bases with RLP, and that's complex. Perfect. Then thank you very much, and see you in 2 weeks at the next breakout call.
Cheers, bye.